A lovely hello to all my 10 champion kids, my dear champions. How are you all? I hope you all are fit, fine, and you all are smiling, shining, sparkling, and most importantly, you guys are preparing for your board examination 2026 with complete dedication. Yeah, I know you have been messaging me a lot, sir. We want one short video of circle. Yeah, you have messaged me a lot, and this is your demand. So the wait is over. I'm here with one short video of circle. Look at the screen, and this video will be game changer for you, because in this video I have explained each and every topic of circle. So just watch this video till the end and ensure your 5 to 6 marks in your board examination 2026. So this video is going to be game changer for you. So stick with me and kindly watch the video till the end, my dear lovely kids. So let's begin without wasting a second. So let's begin. So look at the screen here. Very first, you must know what is circle. What is called circle? You should know the definition. You must know the definition first, what exactly the circle is. So look at the definition here. Very easy definition in very easy words. A circle is the set of all points in a plane that are at a fixed point from a fixed distance from a fixed point. So basically, circle is what? Circle is the collection of so many points. Circle is the collection of so many points in such a way that the collection of those points, let's say I'm marking here, these are the points, so many points, and the collection, this is the collection in such a way that are at a fixed distance, means the distance of this dot from this point, the distance of this dot from this point, the distance of this dot from this point, each and every distance will be equal to each other, and this whole collection of points will be called as circle. And this fixed point here at the middle, this is called basically center of the circle, and this fixed distance is called radius, and the complete geometrical shape that we will get is called circle. Circle is nothing. The circle is the very easy definition is the collection of so many points from a fixed point in such a way that the distance from the fixed point to those points, the collection, will be equal to each other. Every distances will be equal to each other. These all distances are equal to each other, and this collection, this geometrical shape which is forming here is called circle. Right? Now center, I have already told you, the fixed point is called center, right? And radius, the fixed distance, this distance is called radius. I hope this is clear to you, everyone. And now the diameter. Diameter is nothing. Diameter, a chord passing through the center. Like if this is a circle here, and if I take 2 points on the circle, A and B here, so the line joining AB is called chord, right? And if this chord passes through the center, this chord is called basically diameter. And generally diameter is nothing. Diameter is the twice of radius. Right? This is radius here, and this is center, this is radius. So radius plus radius, this is the diameter here. So diameter is basically twice of radius. So diameter is also a chord. I'll let you know later, just 2 or 3 minutes later, what exactly the diameter is. So basically initially you have to keep remember this formula. What is diameter? So diameter is a chord. Actually this is a chord, but it passes through the center, and this is the longest chord of the circle. I'll give you the complete concept, what exactly the chord. So let me give you the clarity of chord here. Basically, my dear lovely kids, if this is a circle here, there are 3 positions of points. If we relate any point from circle, there are 3 positions. One position, a point can be outside the circle, a point may be on the circle, and a point may be inside the circle. So this is called exterior point, this is called interior point, and this is called on the circle. A is exterior point, C is interior point, and B is basically on the circle. So if I take 2 points, any 2 points on the circle, I am calling this point D. There are 2 points B and D on the circle, on the boundary of the circle. And if I join these 2 points, so this line is called chord. This is called, by the way, chord. So what is called, my dear lovely kids? The line joining of 2 points kept on the boundary of the circle. If there are 2 points are on the circle and we are joining those 2 points, that the line forming is called basically. If I take one point is here, P point on the circle, and other point Q is on the circle. If I join P and Q here, so the line PQ is called chord. There can be so many chords. Yes, so many chords will be there. So what is the definition? The general definition of chord: the line joining of 2 points on the circle is called chord. Right? So let me give you one more very important information, guys. Let's say this is a circle and I'm drawing so many chords here. One chord I am taking center here. 2 chord, third chord, fourth chord, chord. This will be chord, this will be chord, this will be chord. And if I ask you, my dear champs, how many chords are there? So you will answer me, sir, there are so many chords. And if I ask you again, which chord is the longest chord? Then you will give me the answer as, sir, the chord which passes through the center. Because as we are moving in this direction, the length of the chords are increasing. And once as reached at the point this, at the center, we got the longest chord. And as we move, away from this line, again the length of the chord is decreasing. Means it implies that this line is the longest. The middle one is the longest line, and basically that is a chord. Longest chord, and that line is also passes through the center. So this line has some spatial identity. The first identity is that line is the longest line, and the second identity is that line is passes through the center, and that is why it is having spatial name. Its name is spatial, and that spatial name is called diameter. So in simple words, you can define the diameter. The longest chord of a circle is called diameter. Or you can also define in your words, the chord which passes through the center is called diameter. Yeah, twice of the radius is called diameter. So basically this. So that's why I'm writing a d is equals to 2. I hope you have understood the point. If you guys are still having any kind of problem, any doubts, just put your feedback, put your question and query in comment section. I'm here for you, everyone. You all are very important for me, guys. So don't sit with doubts. Please remove your doubts before your exam, before sitting in the examination hall. Toppers do the same. Topper never, keep their doubts inside them. They used to resolve their doubts. And keep this mindset on. Please remove the doubts before the exam. Yes, don't think I can do tomorrow, I can do day after tomorrow. Please remove the doubts right away, right now. Okay. So next point is tangent to a circle. What is called tangent? Look, a tangent is a line that touches the circle at exactly one point. Yes, my dear lovely kids, let's say this is circle, okay, and a line, I'm taking a point on the circle, a line which just touches the circle at that point. The line which just touches the circle. Just I'm taking, I see what I'm saying. I'm saying just touches. So how many points will be there? Only 1 point will be there. So this point is called, this point is called, my dear lovely kids, point of contact. This is called what? Point of contact. And this line which is touching the circle, this line is called tangent. Yes. The point at which this line is touching the circle is called point of contact, and that line itself is called tangent. I hope you got the point. The line which touches the circle is called tangent, simple. And tangent is what? A tangent is a line that touches the circle at exactly one point. A line is passing and just touching the circle. Now the third point is secant. A straight line that intersects the circle at exactly 2 points. Yes, my dear lovely kids. If I consider this circle again and I am drawing a line this way. Now look at this line here. This line is not touching. This line is just intersecting the circle. And if I draw a straight line passing through the circle, so how many points will be there? Intersecting points? There will be 2 intersecting points. If a straight line passes through any circle, there will not be more than 2 intersecting lines. Only there will be 2 intersecting. Yeah, if the line is touching the circle, just touches the circle, that will be exactly 1 point. But I'm saying if the line is passing through the circle, if a line is intersecting the circle, so how many points will be there? How many intersection points will be there? There will be 2 intersecting points. So this is 1 intersecting points and this is 1 intersecting points. So this line is called, my dear lovely kids, secant. Keep it in mind. The line which touches the circle, tangent, and the line which intersects the circle. And how many intersection points will be there? 2 intersection points will be there. So that line is called secant. I hope you got the point. Now just give me the answer. Please use your mind and give me conceptual answer. Let there is a circle and this is a point, exterior point, and I want to draw tangents from this point. One is one exterior point. So how many tangents can be drawn from this point? First tangent, and this will be second tangent. How many tangents we can draw from any exterior point? Only 2 tangents. From outside the circle, only 2 tangents can be drawn. Please keep it in mind. We cannot draw more than 2 tangents. Only 2 tangents we can draw if the point is outside the circle. But if I ask you how many seconds we can draw from this point. How many seconds? You know the definition of secant, the line which intersects the circle. So this will be secant, 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 secant. So many seconds. So from any exterior point, only 2 tangents can be drawn. But from any exterior point, how many seconds can be drawn? So many. So many seconds can be drawn. So this is the difference. These are the properties. Please, you have to keep these things also in mind. Difference between secant and tangent. I'll give you a relationship between tangent and secant. That is called secant tangent formula later on. Please watch the video. I will give you a formula also that will be relating secant length and tangent length, and that formula is magical. So watch the video. Okay. So I hope you got the point. Now, very important, without wasting a moment, the theorem which is very important for 10th class student to do the questions that is frequently asking in board, frequently coming in board examination. So I'm moving towards the theorem, very important theorem, and very first theorem, that is theorem number 1, and very important theorem. I'm putting here 3 stars, but this formula basically deserves 5 to 10 stars. I'm putting only, so let's say I'm 5 stars. Very important theorem. Look at the theorem, my lovely kids. So the theorem is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Yes. Let's say, my lovely champ, let me show you the proof of this theorem, what exactly the theorem is. So the theorem is, let's say I have a circle, and the theorem is saying that if there is a circle, and let me draw the tangent here at this point. Let's say this is a tangent. The theorem says that, the theorem is saying that if I draw a radius through the point of contact, to any tangent, this is the point of contact. The point at which the line is touching, that is called point of contact. And if I join the center from this line, this always makes 90-degree angle. It always makes 90-degree angle. Means the radius drawn at the point of contact will always perpendicular to the radius through the point of contact. Means this angle will be 90-degree. If I take one more tangent here, let's say this is a tangent here, this will be point of contact, my dear lovely kids. And if I draw radius here, again the angle will be 90-degree. So the radius makes always 90-degree angle at the point of contact of tangent. A very important theory. It will help you a lot in so many questions. And if you'll go through the previous year paper, the question is definitely has been asked by board examination based on this theorem. You will get so many questions in previous year based on this theorem. So this is very important, guys. So radius always perpendicular to, this is the sign of perpendicular, means 90 degree to the tangent. You might be thinking, some of you might be thinking, sir, how we can say that this is 90 degree. So let me give you a short proof. Let me give you a short proof how you can conclude that the radius always make 90 degree angle with the tangent at any point of contact. Let me show you. Then I will come to this topic as well. First, let me show you this. Okay. So, look, the theorem first is not just theory, only theory. This theorem itself has come in the form of question in previous year, and I mentioned here the previous year in which year this question has been asked. The year 2009, 2012, 14, 15 and 16. This question is as it is came in the form of this theorem. Has come inside in the form of question in previous year. So look at the level of this theorem. So let me show you the proof. Okay, so the question is, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Let me show you the proof. Please watch the video. Okay, so let's say this is a circle and this is a tangent here. Okay, and here is the radius O, and this point I'm calling this point as P. Okay, what we need to prove, what we have to do here, we have to prove that the tangent at any point of a circle is perpendicular to the radius. So I'm drawing the radius first. This is the radius. We have to prove that this angle here, the angle will be 90 degree. This angle will be 90 degree. We have to prove this angle as the I don't need to draw the 90 degree before. We have to prove first, then we can show the 90 degree angle here. So let's draw the radius only. This is the radius. So how we can prove it? Just see. Let's say, my dear lovely kids, I'm taking a point here, I'm calling this point as Q. I'm taking one more point on the tangent, on the straight line, which is tangent, and this point I'm letting that point as Q. And if I join this Q from O, from center, what you can observe here? Yes, if I join O from Q, and Q is what? Q is exterior. You all can see this point is basically exterior point. This is outside the circle. And if I join O from Q, this OQ is intersecting the circle at this point. I'm calling this point as R, where this line OQ is intersecting the circle. Now, my dear champ, just give me one thing. If this is R, which is on the circle, this is P, which is on the circle, hence we can conclude that here OP is equal to OR. Can we write this? Because R is also on the circle and P is also on the circle, because P is the point of contact. And we have taken Q point on the tangent, and Q is exterior. So can we write OP equals to OR, and which is basically nothing but radii of the circle. Yes, my dear champ, and I'm calling this equation number 1. And look, if this point this point Q is outside the circle and R is on the circle, it implies that OQ will be greater than what? OR. Yes, because R is exterior, because Q is exterior point and R is on the circle. So anyone can, even a blind person can see OQ will be greater than OR. Geometrically this is proved. OQ is greater than OR. Now, if OQ is greater than OR and OR is already equal to OP, so can we write here OQ will be greater than OP also. We can write here from first. OQ will be greater than OP. This OQ will be greater than OP. Means OP is the shorter side. Yes, if I take another line here, one more point here, this point will be outside the circle. This point will be again outside the circle. This point will again be outside the circle. So which point is the closest to A? Shortest. So P will be, OP will be the shortest length, shortest line to the point of contact, to the tangent. So it implies that OP is the shortest line to the tangent at P. So we can write OP will be perpendicular to what? I can call this tangent and AB. I'm calling this tangent at AB as AB. Hence proved. This is the proof. Simple. If I ask you guys how I have proved it, let me summarize it in shorter words. Let's say this is a line and there is a point A, and if I ask you draw a line shortest line to this, draw a shortest line to this line, given line. So would it be this line? This will be shortest. Would it be this? Which will be the shortest line? The line which will be exactly perpendicular. That line will be the perpendicular line. And the same story is happening here. Same story is here. This is the radius. Okay, this is the radius, and which will always be 90 degree, because the radius is the shortest line to this tangent. I hope you got the point. So OP is always 90 degree, will always be 90 degree to the tangent. So I can say simply the radius always make 90 degree perpendicular angle at the point of contact to any tangent. Please keep it in mind. This is very important. So now I have told you earlier that I'll come to this point later. So let's say, what is this point here? Number of tangents from a point. So let's say, my dear lovely kids, this is a circle here. Wow, super. Look at the circle. So from external point, how many tangents you can draw? If I ask you, there is external point, how many tangents? One tangent and two tangents. So two tangents can be drawn from any external point. Two tangents. How many tangents we can draw? Internal point. If the point is inside the circle, how many tangents? No tangents we can draw. If the point is inside the circle, we cannot draw any tangent, because the definition of tangent is the line which touches the circle. If there is a point and which is inside the circle, we cannot draw any tangent at the circle, because if the point is inside, the line will be intersecting, right? The line will be intersecting, so zero tangent. If from a point on the circle, if a point is on the circle, this point on the circle, how many tangents we can draw? Yes, of course we can draw one tangent. So one tangent. I hope you got the point. If a point is exterior, how many tangents? Two tangents. If a point is interior, inside, no tangent will be there. Yes, second will be there. There will be second. And how many seconds? So many seconds. If the point is inside the circle, look, this is a point. How many seconds? 1, 2, 3, 4, 5, 6, 7, 8, 9. So many seconds will be there. But tangent will be 0. I hope you got the point. Now, theorem number 2. Theorem number 2 is the converse of theorem number 1 is also true. Yes. What is theorem number 1, my dear lovely kids? The theorem number 1 was, I have just explained you, there is a tangent, and if we draw a radius at the point of contact, the radius always make angle 90 degree. And there is a reverse process also. Here in this proof, what information that was given to you? The information is given that this is tangent and this is radius. You have to prove this angle 90 degree. But the reverse is, if the radius is there and the angle 90 degree is given to you, and this line this line is not sure. I'm not calling this tangent. I'm calling this is an ordinary line, any line. We have to prove that this is a tangent. How we can prove it? So let me show you the proof of this. Very interesting. So for this, I need a circle. So let's say there is a circle. How is the circle, guys? What happened to me? I am drawing such a beautiful circle. Look at my circle. Even you cannot draw this circle like this circle on your paper, you know, using compass. Look at the circle, the beauty of the circle. Wow. I'm myself amazed. Okay. Superb here. So let's see. So there is a line. See, I'm calling this line. I'm not calling this tangent. I'm calling this line. Okay, and there here is center, and this is radius, and this is 90 degrees. This is given to you. This is radius and this is 90 degrees. This is given to you. Don't worry for that. This is given to you. Radius is here. This is radius. This is 90 degree, and this is our line. We have to prove. We have to show that this line is tangent, because the earlier theorem was what? This was tangent and this was radius. This information was given to you. This is a tangent and this is radius. Okay, and we have, look, this is a tangent and this is radius, and we had to prove 90 degree angle. But here in this topic, the information is already given to you. This is 90 degree angle, and we have to prove that this line will be tangent. And tangent, the definition of tangent is what, you know, the line which touches the circle at single point. At single point. So how we can you prove this? Among all line segments, if I draw, like this is O point, and I'm calling this as P. You know, if I ask you, my dear champs, if I draw here, you know, so many lines on this line, if I join, I'm calling this as A. I'm taking so many points on this line. Okay, B. Here is C. Okay, I have drawn OA, OB and OC, and this is already radius, which is OP. And if I ask you in these four lines, OA, OB, OC and OP, which line is shorter? Which line is the shortest? So I hope you can see here, these points A, B, C are the exterior points to the circle. And only P point, this P point is on the circle. So if these points are the exterior and P is on the circle, it implies that P is much closer to O. Yeah, P will be the closer to O, and if P is closer to O, the OP distance will be the shortest one, because A, B, C, they all are exterior point. So here the concept is, look, if I take this one OA and I'm calling this point as here, I'm calling this D. So look, my dear lovely kids, among all line segments, among all line segments, OA, OB, OC and OP, among all line segments OA, OB, OC and OP, OP is the shortest. OP is the shortest. I'm not creating this line statement by my own. No, geometrical situation is saying that. Look here. Look here. Here, OD, this is OD and this is OP. Both are radius. This will be also radius from here to here. So I can write here OP equals to OD, and I can mention here what? Radii of the circle. Are you agree? Say yes or no. We can write OP equals to AD, and both OP and OD are the radii. Is it clear? Now, D is on the circle, A is outside the circle. So geometrically, OA will be greater. Now, OA is greater than what? OD. Yes, by geometry. By geometry, I can write here by geometry. Why I am writing this line? Because A point is outside the circle. So if OA is greater than OD and OD is greater than OP, so we can conclude here OA will be greater than OP. And this implies that similarly, if these, look at these three points, if you compare OP from OB, same condition will occur. If you compare OP from OC, same situation will be occur. So which one is the shortest? It implies that OP is the shortest line segment from the center to the tangent to the line touching the circle. I'm not calling that line tangent till yet. To the line touching the circle. But one thing is clear, na? If OP is the shortest point, shortest length, shortest line, so there will be only one point. There will be only one point in the form of P. So means that line is passing through that only one point. Hence, so the given line is just touching the circle at one point, because there will be no any other line other than OP which will be shortest. OP is the shortest, so P is single. P, the identity of P is only one, so the line is just touching the circle at only one point, and this is the definition of tangent, at one point. So the line is a tangent. I hope you got the point. So this is the proof, how you can prove. I hope you got the point. Please write that in solution. Okay, now moving to theorem number 3. Theorem number 3 is the, wow, superb, very important. See, in the chapter circle, theorems are very important, because you know, I'm not saying, I don't need to say most, I think I should not say most. Every question I can say 98% question will be based on this theorem. I'm teaching you all guys. Theorem number 1, theorem number 2, theorem number 3. These all theorem are very important for you guys, my dear champ. So let's move to the theorem number 3. I've already written here, very important. So now look at the theorem. So the theorem is that lengths of two tangents drawn from an external point to a circle are equal. Do you understand the given language? Have you understood the situation? What exactly the situation is? Length of two tangents drawn from external point. Let me show you by diagram, and let's prove it. How? I'll prove it also. So directly I'm going to prove. Okay, so let me use, I think yellow color is visible, most visible to you guys. Okay, so let's say there is a circle. This is a circle, my dear champ. Okay, and there is an external point. This is an external point. Theorem is saying that lengths of two tangents drawn from an external point. So if I draw a line this way, my dear champ, if I have drawn this line and this line is going this, where the line is going doesn't matter. You have to consider the line till the point of contact. Yes, this is called tangent, length of tangent. You don't need to move away from this point. If I ask you what is the length of tangent, then you have to measure the length from this to this only. You don't need to measure the length of this, because the tangent is from the point from which the line is drawing till the point of contact. Simple. And this is called the length of tangent. I hope you got the point, right? And if I draw one more line here, this form, wow, this line is touching the circle, so this is also a tangent. Earlier, what I was saying? I was saying a line. But as this line is touched the circle, has touched the circle, I'm calling this a tangent, because this is the definition of tangent, if a line touches the circle. So this is external point, and this is tangent, and these are the point of contact. So let's call this point of contact A. I'm calling this point of contact A and this as B, right? And this is what? Exterior point, external point. But we have to prove, if we draw tangents from any external point, the tangents are equal to each other. I'm calling this A and this is P. This point is P here, my lovely kids. And these tangents are always equal to each other. This is the theorem. But the question you might be thinking, the question might be arising in your mind, my dear kids, how, sir, how you can say this? How? Is there any mathematical proof? Let me show you the proof. So let's draw the center. This is the center and this is point of contact. You guys know, yes, if I join this point of contact from the center, the angle will always be 90 degree. The first theorem, if I draw the radius here at this point, the angle will be 90 degree. This is the first theorem. And if I join this from external point, look, this. So there will be two right angle triangles. One right angle triangle is, you know, this is O. One right angle triangle is what? Let me draw O using red pen, because I have labeled each and every point using red color. So it should also be from red color. So this is O point. So how many triangles are here, my dear lovely kids? There are two right angle triangles. One right angle triangle is PAO and other is PBO. So let me prove these triangles are congruent to each other. If we prove these two triangles are congruent to each other, then by simplicity we can say PA and PB are equal to each other. And this is the theorem. Always the tangents are equal to each other. So let me show you. In triangle PAO and triangle PBO, can we write this? I hope this is clear. Now angle PAO equals to angle PBO, we can write this is 90 degree. We can mention the reason here. You can write here by theorem 1, or you can also write here radius drawn, radii, because both I'm applying at both positions, so I'm calling radii drawn at the point of contact. Either you can write by theorem 1 directly, or you can also write radii drawn to the point of contact. Okay, now look at here. Now the condition is here, this is OP is equals to OP, because OP is in both the triangle. You can see here OP, this is OP, this is in this triangle as well as in this triangle. So OP is equals to OP, and we can mention here common, because OP is in both the triangles. And now look, this OA is equals to OB. Why? Because this is a radius and this is a radius. We can write here what, my dear lovely kids? Radii of the circle. Yes. So look at this, my dear lovely kids. APO equals to PBO. They both are equal to 90 degree. R, 90 degree means R, right angle. OP is the hypotenuse of this triangle as well as this triangle, and this is the side. So by RHS congruency, you know, triangle AP PAO is what? Congruent to triangle PBO. If both the triangles are congruent to each other, can we conclude PA is equals to PB by simplicity. Hence proved. This, and one more thing, my dear lovely kids, this theorem can also be proved by using Pythagoras theorem. Yes, you can apply Pythagoras theorem in this triangle and this triangle, you will get the result. They both are equal to each other. So this is very important. So let me ask you a question here. Very easy question, my dear lovely kids. If this is a circle and from this external point I have drawn this tangent and this tangent. Okay, this is of 2 centimeter and this is of x. So what will be the length of this tangent? Simple, this also will be 2 centimeter. Okay, so this is the theorem. The tangents drawn from any external point are always equal to each other, right? So let's move to second here. So I have already told you about second, but the most important thing is here the relationship between tangent and secant, and this theorem is called tangent secant theorem. Very important theorem. The question, might you get in board examination on the relationship of tangent and secant. I'll not go through the proof, that not required here, but you should have the formula. Okay, so let me give you the clarity on secant and tangent theorem. So let's say, my dear lovely kids, this is a circle here. Let me draw a bit smaller circle because I need space. So let's say, my dear lovely kids, this is a circle here, and from an external point, this is an external point, I am drawing a tangent, tangent because this line is touching the circle, and I have drawn a secant also. This is secant here. So from an external point we are drawing 1 secant and 1 tangent. Tangent will be till here, and this secant always intersects the circle at 2 points. So if a secant and tangent are drawn from a point outside the circle, we have applied here. Tangent square, let's say I'm calling this as P, this point A, this point B, and this point C. So what this theorem says, the tangent square means the tangent is PA. So PA whole square will always be equal to external part of secant. Which is the external part of secant? This is BP. External part, secant is divided into 2 parts. One is external, other is inside the circle. So external part PB into whole secant, and whole secant is what? PC into PC. This is the theorem, my dear lovely kids. Please keep it in mind, this formula. I don't require to go through the proof. I can do for you, but not required. So please keep it in mind, this formula. Right? So this is the formula. P, if P is external, PA is tangent, same PA is tangent, and PBC is a secant. PBC is secant. Right? So if the length of tangent is 3 centimeter, let's say 3 centimeter, what I am writing, why I am writing double C here? So let's say this secant is of 4 centimeter, right? And the inside part is 2 centimeter, right? The inside portion is 2 centimeter and the complete secant is of 4 centimeter. What will be the length of tangent here? So we can use this formula. PA square will be equal to PB is what? PB is what? PB. What will be this? If this is complete 4 and this is 2. So what will be remaining part? 2 into what? PC. PC is complete 4, right? So PA will be 2, 4, 8 under root 8, and the under root 8 will be 2 root 2 centimeter answer. I hope you got the point. So this is the relationship between this very important formula. Please keep it in mind, my dear lovely kids. Let's move to next question number. So this question, basically this was the proof of theorem number 1. This is theorem number 1 and this was the proof of theorem number 1. But as I have already told you, this theorem, the proof of theorem number 1 is already been asked in board examination in the form of question. So I have given question number 1 here. So moving to question number 2 here, look at the question number 2. Can you do this question? Can you guys do this question? Okay, if you, many of you, some of you might be still worried in circle. I am here to make your circle stronger. Just watch the solution. In the given figure, PQ, why R is here? R is not required. PQ is a tangent at a point C to a circle. Very good. Center is O. if AB is a diameter and angle CAB is 30 degree, then find PCA. My dear lovely kids, to solve this question, let me give you a small concept here. In any circle, if this is center and this is diameter, so angle in semicircle, this part will be semicircle, and I'm drawing an angle here using two extreme point of this diameter. So this angle will be always 90 degree. Wherever you can take the angle, wherever, the angle will always be 90 degree. And this is called angle in semicircle. This always be 90 degree, please. Because this information we will use here. So how we can find the solution? Look, very easy. So we have to find here what? PCA. Where is PCA? PCA, we have to find this angle. Okay? Oh, I think yellow color is not showing to you guys. So we have to find this angle here. PCA. How we can find this angle? So my dear champs, look, if O is the center, means AB will be diameter, AOB will be diameter. And if AOB will be diameter, what will be this angle? This will be 90 degree. Yes, angle in semicircle. Yes, angle in semicircle. Now do one thing. We have to find this angle. One information is given to you. Angle CAB, where is CAB? CAB, this angle is given to you. What is this angle? This angle is 30 degree. If this is 90 degree by angle in semicircle and this is 30 degree already given, what will be this angle? 9, 3, 120 and 120 there, so this will be 60 degree. I hope you got the concept. Now, what is the theory here? Let me show you. So, can we join this O from C? This is center and this is point of contact. If I join this O from C, if I join this O from C, this, so there will be this radius 60 degree, 60 degree. If this is 60 degree, this is 60 degree, what will be this angle? Wow, this will be also 60 degree. Let me erase the all points. See what I am doing here. If I join C from O, what will be the scenario? Wow, this angle will be equal to this angle, and this angle will be equal to this angle. And the complete angle, look, this is the PCA. I'm giving the solution here. Angle, this angle, ACB equal to what? 90 degree? How? Angle in semicircle. Angle in semicircle. Okay? Is it clear? Angle in semicircle. Now, angle CAB equal to 30 degree, and which is already given. So what angle? This angle in triangle, what triangle? BOC, what? The story will be in triangle this, in triangle ABC first. ABC, in triangle ABC, what will be the story? Can we apply angle sum property? Angle ACB plus angle CAB plus angle what? ABC will be 180 degree by angle sum property ASP. So we can find here angle ABC. ABC will be 180 minus these two, and ACB is what? 90, and this is what? 30, 90, 30, 120, and here this will be minus 1. So the angle ABC will be 60 degree. I hope you got the point. And here, if ABC is 60 degree, what will be this angle? This angle will also be 60 degree. Wow. Now, OB equal to OC. These are the radii. If OB equal to OC, so angle OBC will be equal to angle OCB. Yes, if this side is equal to this side, so this angle will be equal to this angle. By angle sum property, by reverse property of isosceles triangle, by isosceles triangle, right? So angle OCB will be this is ABC. This I'm calling this ABC. So this will be OBC same. So this will be 60 degree. The story is finished. If OCB is 60 degree and this complete angle ACB is given to you, this complete angle 90 degree. So now, so angle ACB, this ACB is equal to what? Angle OCA plus angle what? OCB. We have just got here. So ACB is given to you. ACB is 90 degree. Look at the line here. ACB is 90 degree by angle sum property. So this is 90 here. OCA, I don't know OCA. We have to find OCA. Angle OCA and OCB is given to you 60 degree. Right? So can we find OCA? Angle OCA will be 30 degree. Is it clear? And if OCA, you have OCA, you have got the values of OCA. This is 30 degree. This is 30 degree. And this complete is 90 degree. Because this is the radius. Hence, we have to find ACP, PCA, simple. PCA is equal to what? Angle OCP minus what? This angle OCA. Angle OCA. Right. So angle PCA will be, OCP is what? OCP. This is 90 degree complete because this is the radius. And this is the point of contact. So this will be 90 degree. 90 degree minus OCA. This we have already calculated. This is 30 degree. So angle PCA is equals to 60 degree. Answer. Simple. Very easy question. I hope you have understood the concept. Please write down the solution. Okay. I hope you have taken the screenshot of the solution. Okay. Now moving to question number 3. In the given figure, triangle PQR circumscribes the circle. If PX equal to 10 centimeter, very good. QY is 8 centimeter, RZ is 6 centimeter. We have to find the value perimeter of, very easy question. We have to find the perimeter of PQR. You know, perimeter means the sum of all the sides of triangle. Look. So, very easy question. So, I'm starting from point number P. So, point P is exterior point to the circle. So, we are drawing two tangents, PX and PZ. And we know by theorem 1, the tangents drawn from any exterior point are always equal to each other. So if PX is 10 centimeter, so what will be the length of this? This will also be 10 centimeter. Simple. Simple. Right? And if this QY is 8 centimeter, so what will be the length of this line? This also be 8 centimeter. Because these are the tangents drawn from this one point. And here same situation, from R point we are drawing this tangent RZ and RY, and if this is 6 centimeter, so what will be this? This will also be of 6 centimeter. And perimeter of triangle, perimeter of triangle PQR will be equal to sum of all the sides. PQ plus, this is PQ plus QR plus RP, right? And PQ is what? PQ is this, which is equals to, 8 plus 10. Basically, PQ is what? PX plus XQ, and 10 and 8. So we can write here 10 centimeter plus 8 centimeter. Now come to QR. QR is this, and this is QY 8 centimeter. This is 6 centimeter. So 8 centimeter plus 6 centimeter. And this is what? RP. RP is what? 6 plus 10 here. So 6 centimeter plus 10 centimeter. Now add these points. So 10, 10, 20, 20, 20, 60 here, and this is 12. So we can write here, look, this is 16, 16, 6, 22, 22, 8, 30, 30 or 8, 38, and this is 48. So the perimeter of the triangle is 48 centimeter. Very easy question. Very easy question. I have just applied the theorem, and this is very most recent question. Wow. Very easy question. I hope you have understood it. Moving to question number 4. Two tangents TP and TQ are drawn to a circle with center O from, see my dear lovely kids, I have picked up here very important question, and the questions those are the question which are pillar foundation of the circle. You most probably you might get this question anywhere, where in your either in your pre-board exam, in your any book, in your reference book, whatever. These questions are foundation of circle. So that is the reason why I picked up these questions, so I can give you the complete clarity of circle. So this question is been asked in the year 2009, 2014, 17, 20 and 23. So now you can understand the worth of this question, importance of this question, guys. So now solve this. Two tangents TP and TQ are drawn to a circle, very good, with center O from an external point T. Prove that PTQ, where is PTQ? PTQ, wow, this angle is equal to twice of OPQ. Wow, twice is of OPQ, center is O, very good. One information is clear, this is the center here, and we have to prove this angle is the twice of this angle, very good. Can I use here blue, white color? I think white will be most visible. Okay, let's prove. So what we need to do, let me give you the concept. We have to prove the relationship. Don't go to what exactly the question is asking. Just look at what is the relationship. We have to derive the relationship between TPQ and OPQ. Just keep it in mind. Stick with that situation. You have to derive at anyhow. You have to derive the relationship between PTQ and OPQ, and you will directly get this as it is relation. So how we can reach to that extent, so that we can prove the relationship, we can get some relationship between PTQ and OPQ. Let me give you the concept here. So my dear kids, this is that external point. So you all know, if this is T, this T is external point, so this will be, this TP and TQ will be equal to each other. Both the tangents will be equal to each other. This is clear. And if both tangents are equal to each other, these angle will be also equal to each other by isosceles triangle. This is not my homemade property. This is the property of an isosceles triangle. If the sides are equal to each other, then the corresponding angles are also become equal to each other. That is the point here. Okay, so we can write here, if TP equals to TQ, angle what? TPQ will be equal to angle what? TQP by an isosceles triangle. I hope you get the point. Is there any doubt till now? No doubt? Let's move ahead. Now my dear lovely kids, if this is a triangle, now I hope red color is visible to you guys, everyone. Now in triangle TPQ, in triangle TPQ, angle TPQ plus angle PTQ plus angle PTQ plus angle TQP will be equal to 180 degree by angle sum property. You all know, in any triangle, the sum of all the angles are equal to 180 degree. And we have already got this relationship. TPQ and TQP both are equal to each other. And if they both are equal to each other, see, if I want PTQ, so PTQ is already here. And I want to OPQ, and OPQ is here, which is close to TPQ. Which is neighboring to TPQ. This OPQ is neighboring of TPQ. So TPQ is here and TQP is here. So can we replace this TQP from TQP from TPQ? Why TPQ? Because we require TPQ, because TPQ is close to OPQ. So TPQ plus angle PTQ, and this has been replaced from this TPQ. PQ. Let's say call this equation number 1 equal to 180 degree, and you can mention here from first. I hope now the thing is clear to you, everyone. Can we write this as PTQ will be equal to 180 minus this is TPQ and this is TPQ. One TPQ, other TPQ will be 2 TPQ minus 2 TPQ. So angle PTQ will be equal to 180 minus 2, and look, this is TPQ. Where is TPQ? This is TPQ. And you all know if this O is radius, so this will be 90 degree, this complete angle. So can we write here angle TPQ as what? Angle, OPT minus angle OPQ. Are you agree, guys? Are you agree? This look to T, where is TPQ? This is TPQ. So this will be 90 degree, which is OPT minus this. If I subtract this small angle from this whole angle, we will get this angle. So angle TPQ can be right. This OPT is what? OPT is what? 90 degree minus angle OPQ. So we will replace this whole format here. So TPQ I can replace by 90 minus angle OPQ. I hope you get the point. I am calling this as equation number 2. So we can mention here from equation number 2. I hope you get the point. Now look, angle PTQ equals to 180. 90 into 2 will be 180, and minus will be plus angle, and 2 is there, 2 is already there, OPQ. So 180 plus minus cancel, and this angle PTQ is equal to angle twice of angle OPQ. Look, this is the proof. Angle PTQ equals to 2. Very easy proof. You may find this solution is very easiest one. You might get the solution of this question somewhere else, but the way I solved this question is very easiest. I think you can follow all. Okay, I hope this is clear to you, everyone. So can we move ahead to the next question? Question number 5. A circle is touching the side BC of a triangle ABC at point P and touching AB and AC produced at Q, and are very interesting question, tricky question. Interesting and tricky. Wow. So let's draw the diagram and look how many times this question is asked, has been asked in the year 2000, 2001, 2 and 20. Even this question is given in exemplar. So let's say, so there is a triangle ABC. So I'm drawing in this way. Let's say this is a circle here, and this is okay. This is triangle A, B and C here. Okay, ABC. This is triangle ABC and circle is touching here. Okay, at where they are touching Q and R respectively. So a circle is touching the side BC, very good, of a triangle ABC at P point, very good, and touching AB at Q and R respectively. So this is here, this is Q and this is what? R. And what we have to prove? AQ. To prove, let me change the color of pen. AQ equals to 1/2 perimeter of triangle ABC. We have to prove this. Very interesting question, I can say. Yeah. So let's say how we can prove this question here. So my dear lovely kids, look, if I ask you for this circle, how many points are exterior? How many points are external to that circle? Yes, A is external, B is external, and C is also external. This is the concept. if you can see the diagram clearly, A is external, B is external, and C is also external. So for point A, I am taking point A first. For point A के लिए, so one tangent is AQ because we are drawing this tangent from point A, and other tangent is AR. Hope this is clear to you. We can write the region tangents drawn from an external point, right? Is it clear? 4 point from point A, we can write from also. 4 point B. Now look at point B. B is also external, and from B there are two tangents, BQ and BP. I've already told you, take the tangent till the point of contact. Don't go beyond point of contact. Your length of tangent is till point of contact. No need to go beyond that point of contact. So BQ is equals to BP. Similarly, what? For this C point, what will be the scenario? CR will be equals to CP. I hope this is clear to everyone. I hope this is clear to everyone. Now, can we write this AQ, this complete AQ? Now, I'm doing here. Now, AQ equals to AR can also be written as this AQ. Can we write this AQ as AB plus BQ? Yes, we can write. This AB, complete AB, can be written as AB plus BQ. So AB plus BQ. And similarly, AR can be written as AQ plus CR. AC, this is AC here. I'm calling here this AR. So AR will be what? My dear champ, AR can be written as AC plus what? This is CR. I hope this is clear too. Now BQ is equals to what? BP. BQ is equals to what? BP. So from this position, BQ is equals to BP, and CR, this CR is equals to what? This CP. So can we write this function as AB plus BQ will replace by BP, which will be equal to this AC, and CR is equals to CP. Call this equation number 1. But what we have to prove here? You have to prove the relationship between AQ, this AQ, right? Where is AQ? This AQ and perimeter of triangle ABC. So perimeter of triangle ABC, what? What does it mean by perimeter? The sum of all the sides, and the side is AB, BC, AC. AB plus what? AB plus, this is AB plus BC plus this is what? AC. Is it clear? Now look at the magic. Perimeter of triangle ABC. My dear lovely kids, what is this BC? Can we write this BC as BP plus PC? Wow. AB plus this BC, this middle one, can be written as BP plus PC. And AC is already here. Now look, this, it has become AB plus BP, right? And this is PC plus AC. This is PC plus AC. And look, they both are equal to each other. Okay, and if they both are equal to each other, so this bracket can be replaced by this one. So perimeter P of triangle ABC is equal to AB plus BP, AB plus BP, and I'm writing this bracket AC plus AC, again AB plus BP, plus AB plus BP. I need space, so I'm writing here this. Okay, so perimeter of triangle ABC will become twice of this bracket, 2 into AB plus what? BP. And my dear champ, here is BP, and BP is also equal to BQ. BP is also equal to BQ because this is BP, this is BP, and this is BQ. So both are equal. So perimeter of ABC, perimeter of triangle ABC is equals to 2 into AB, and BP can also be written as BQ. So let me know, just tell me, AB plus BQ is what? This is AB and this is BQ, and this whole is AQ. So can I shift right side to left and left to right? So 2 into AQ is equal to what? Perimeter of triangle ABC. So AQ will be what? 1 upon 2 perimeter of triangle ABC. So this is not a question, this is a formula also. This is a formula. When we can use this formula? When a circle may touching any triangle. If there is any triangle outside and a circle is touching a triangle at any point, so in that situation we can use this formula. So AQ will be equal to what? Half perimeter. We have proved here. Very important. And on the basis of this question, I'm giving you again one more question. Look at the question here. This question is as it is based on this. So what we have to do here, AP is given to you. This, it is given to you. This is, oh, let me change the color. So this is given to you, my dear champ. And this is what? 12 centimeter. We can solve this question by two methods. One, by using this method directly, by using this formula direct. So this is AP. So we all know AP will be what? AP is the tangent, and this is a triangle ABC. So AP will be what? Half perimeter of triangle ABC. And in this question we have to calculate the perimeter. So perimeter will be, if I shift this to here, this side, so the perimeter will be twice perimeter of triangle ABC will be what, my dear lovely kids? Twice of AP, right? So AP is already 12 here, so 12 to 24 centimeter answer. This is the way how we can solve. Okay, so this was first method by using the direct formula on the basis of this, right? This, by we can solve this question by one more method. Let me show you one more method. I'm using blue color. So the second method is, see, if this is C here, and from this C, CD and CQ are drawing. So if I call this Y, so what will be this CD? Y. And if I call this BD as X, so what will be this BP? This will be also X. You all know? Yes. And if this AP is 12 centimeter, so what will be this whole? This will also be 12 centimeter. Is it clear? Now the question is asking to find the perimeter. So perimeter of triangle ABC will be what? What does it mean by perimeter? The sum of all the sides. So if I apply the sum of all the sides, so the first side will be AB plus second side will be BC, and the third side will be what? CA. Now look Look, AB is here. Where is AB? AB is this. This is AB, and this whole is 12. And if we have considered this x, so 12 minus x will be AB. 12 minus x. Plus BC is what? Where is BC? BC is this. BD plus CD. BD plus CD. BC is BD plus CD. And BD is x and CD is y. So can we write here? X plus y. Plus CA. My dear lovely kids, where is CA? CA. This whole is 12. And we have considered this. We have assumed y this. This whole is 12 and this is y. So what will be AC? This will be 12 minus y. So can we write here? 12 minus y. Now we can open this bracket. So 12 minus x plus y plus 12 minus y. So plus x minus y, x cancel, plus y minus y cancel. So 12 plus 12, same answer we are getting, 24 centimeter. So you can apply any method. I hope, my dear lovely champ, this is clear to you everyone. So moving to question number 7, very interesting question. Somehow most probably you can get this question in sample paper or anywhere, online mode and anywhere. This question will be there. I don't know why. This question is evergreen question in circle. So look, very easy question. So my dear lovely kids, my very simple question from you all, which points are the external point for the circle? Just tell me. Which points are the external point of the circle? Yes, A, B, C and D will be the external point of the circle. P, Q, R, S on the circle. That P, Q, R, S are the point of contacts. So how many points are, outside? External, 4 points, A, B, C, D. So if there are 4 points which are external, so if I draw tangent from all those points, the tangent will be equal to each other. That theorem will be applicable here. Only that theorem. The tangent drawn from any external point. So let's take, and we have to prove this. So let's write here. Let me use white color pen. So what we have to prove? To prove AB plus CD is equals to BC plus AD. We have to prove this, right? So if I ask you how you can get AB, AB is this, and AB is summation of AP and PB. BCD is this, and CD is the sum of DR and CR. BC is this, BC is the sum of BQ and CQ. So you have to write in such a way that while doing the addition, you can get this relation directly. So first to do this question, you have to know, search out the external points. How many external points? You have to get that. You have to find that first. How many external points are there? So there are 4 external points, A, B, C and D. So let me show you from external point A. I am taking A first. From external point A, look at the solution. From external point A, where is A? Look, my dear lovely, this is A. So we are drawing AP. Let me take red color of pen. I think red color is visible to you guys. So AP, this is AP and this is AS. And both the tangents will be equal to each other by theorem. The tangent drawn from any external point, from external point A, we can write here AP will be equal to what? AS. We can mention here region, tangents drawn from external point A. I hope you got the point. And I am calling this equation 1. Now write similarly. Now for B point, what will be the scenario? From B point, this will be tangent and this will be the tangent. How many tangents are there? Again 2. So from B point, there are 2 tangents, BP and BQ. Many of you might write BQ, BP as BQ equals to BP. But make sure You have to write this format in such a way. If I write this BQ and BP, if I add this and this, so right side will be adding with right side and left will be with left side. So AP plus BQ, there will be no mean. So instead of writing this format in this way, you can write BP equals to BQ. Why? If I add this and this, AP will be adding with BP and BQ will be adding with BS. So when we adding BP and AP, so BP plus AP will be AB. So the magical thing in this question is how you are writing the situation. If you are writing the situation in proper order, this question is very easy. I can say easiest one. So similarly I can write this as what? BP, and I'm taking this as BQ. Why I'm writing here BP? If I add these two, AP will be added with BP and AP plus BP will be whole AB. And we can write here tangents. I think we don't require to write this again and again because we have already written here similarly. But we can write tangent drawn from the point what? B. And I'm calling this as equation number 2. Now come to this C point. So for C point, what will be the situation? How we can write? This is BQ, this is BQ, and BQ should be added with CQ to get BC. So for this BQ, I'm writing CQ this side, right? And if I'm writing CQ, remaining will be RC. This will be RC, right? And the situation will be tangent drawn from the point what? C. And I'm calling this as equation number 3, right? Similarly, for D point, look here, this is AS and we want AS should be added, AS from DS. So we have to write this side DS because AS is here. And if I am writing DS here, so what will be the remaining? DR will be there. So we have to write DR this side. And situation will be tangent drawn from the point D and call this equation number 4. This is the magical thing, how you are writing these. Now you can add all these 4 situations. So adding all these, so right side will be adding with right side and left will be adding with left. So AP plus BP, I'm taking in separate bracket, and this is what? RC plus what? DR, right? Now make system. If you are taking AS, this is AS. Where is AS? Now you can directly take BQ first. BQ plus B. If this is BQ, so you have to take CQ with BQ, CQ, right? Plus, which are remaining? AS plus this is DS, right? So AP plus BP will be whole AB, right? And RC plus DR will be CD, right? And this is BQ plus CQ will be BC, sorry. And AS plus DS will be AD. Wow, hence proved. Look at the question. The most important thing, how you are writing these equations, these situations, first, second, third and fourth. This is the magical thing in this solution. I hope you have understood the concept. Let's move to the question number 8. So the question number 8 is, in the given figure, O is the center of the circle, MN is the chord, and the tangent ML. Where is tangent? ML. Very good. MN is the chord and the tangent ML at a point M makes an angle of 70 degree. This is 70 degree. Very good. With MN, superb. The measure of angle MN. We have to find the value of this angle. This will be what? So let me show you. If O is the center and ML is the tangent, so what will be this angle? This whole angle will be 90 degree. Here I am solving this question. Here angle OML will be 90 degree. Why? Because OM is perpendicular to ML. Right? I hope you get the point. This will be 90 degree, complete OML. This is the theorem, the radius drawn to any point of contact. Very good. Now, if this 70 degree, so what will be this angle? This whole is 90, this is 70, so this will be 20 degree. Right? I can write here angle OMN plus angle, NML. This is given, na? NML. Angle NML will be 90 degree. Yes, this is basically OML. OML is equal to the sum of this plus this, right? So angle OMN will be equal to 90 minus NML is what? NML is what? This is 70. So I can write 70. So OMN will be equal to 20 degree. And my dear champ, if this is 20 degree, so this will also be 20 degree. Why? Because this is the radius. So if this is 20 degree and these two lines are equal to each other, so by isoscale property this will be, it has to be 20 degree. Yes. So angle ONM will be 20 degree. How? By an isosceles triangle property. I hope you get the point. I hope you get the point. So ONM is also 20 degree. So in any triangle you have two angles. So can you find the third angle? Yeah. Hence angle MON will be equal to what? 180 minus sum of these two, and they are equal to each other. So we can write twice of OMN because they both are equal to each other. So angle MON equals to 180 minus 2 into 20. So this will be what, my dear champ? 180 minus 40 will be 140 degree. Very easy question. Very easy question. So moving to question number 9. Two concentric circles are of radii 5. What do you mean by concentric circles? The circle whose center is same. The circle, so many circles, 2, 3, 4, 5, but the center is common. So there are two circles, one and other. Let me draw one more time this circle. This is not clear. So, okay, this is the circle. These are the circles of radii 5 cm, 3 cm. Find the length of the chord of the larger circle which touches the smaller one. Very good. So this is the diagram. So this line is touching the circle inside, and chord for the bigger circle and tangent for the smaller circle. And here is the center. So if I draw the line here, right, so this will be 90 degree for both. This radius here, we have to find what? Which touches. Find the length of the chord. We have to find the length of this. If I join from this point and this point, right? A very easy question, I think. Very easy question. So the radius of bigger circle is 5 cm. So this will be 5 cm. We have to find the value of this. I'm calling this AB. We have to calculate the length of AB, and this is O. This is what? The radius of bigger circle, which is 5 cm. So this is, my dear champ, 5 cm, and the smaller radius till here, this is, my dear champ, this is how much of length? 3 cm. And you all know, I'm calling this point as M. So angle here, angle OMB will be 90 degree. Why? Because this is the center, this is the radius, and this is the tangent for smaller circle. So radius drawn at the point of contact, to the point of contact, I'm writing it to the point of contact. So if I draw the radius to the point of contact, the angle will be 90 degree always. And if this is 90 degree, can we apply Pythagoras theorem? Yes, we can apply Pythagoras theorem. So, OB square equals to what? OM square plus what? MB square. Why I am writing this? By Pythagoras theorem, right? So we have to find MB first. If we can find MB, we can find complete length. So MB square will be what? OB square minus, I'm shifting this OM this side, OM square, right? So MB is what? I don't know MB. We have to find out the MB square. OA, OB is what? This is 5 here. So 5 square minus OM. OM is the radius of smaller circle. So OM is 3 square. So MB square, 5 square 25, 3 square 9. So MB square is equals to what? 16. So MB will be under root 16, and we know under root 16 is equals to 4. So plus minus 4, but we have to take length. We are finding length, so we can conclude only positive. So we got the value of this MB. Similarly, if we can apply Pythagoras theorem here in this triangle, so again this will be same length, because this radius is 5, this is 3. So same length will be, means this is 4 and this is 4. So what? We have to find the length of AB. So AB is what? Twice of MB here. We can conclude, we can write here. So AB equals to 2 into MB is what? 4 centimeter. So AB equals to 8 centimeter. Answer. So I hope, moving to, wow, thank you. Moving to the completion of this chapter. So successfully we have finished. I hope this session, this video may be helpful for you guys, because I have covered each and every corner, each and every part of topic of circle, and this one short video. Kindly go through the video again and again, and do the question by your own, because I have picked up very important question. Each and every questions are important, and you may get this question in your pre-board examination, in any upcoming exam, even in board exam as well. So this is my assurance. You will be remembering me while you will be writing your exam, sir, and you might be expressing gratitude and love towards me, because I have done here so many questions, and all the questions are very important for you guys. So my dear lovely champ, my 10th kids, my champion, my blessings are always with you. If you guys have any kind of query, problem, challenges you are facing while doing the question, while preparing for your board exam, just let me know. Put your problem and write your problem in comment section. I'll get back to you. I'll give you the complete solution, resolution to all those problems you are facing right away, because we are here and you all are very important for me, because we are also expecting and we are looking forward to see you as a topper in board 2026. Thank you so much for watching. Stay blessed, take care, and let's meet in next video. Thank you so much. Bye bye.